Hello, Racing to Green here, bringing you part 2 of our Internet Smart Garden build. In this part, we're going to be covering the parts used and why we use them. As you can see, the Smart Garden is coming along. We've got the solar panel mounted and the control box installed. As you can see, we can read moisture, temp, and now voltage. But let's get to it. So all told, for the basic kit, it costs nearly $300, but most of that was for the IoT Explore kit and the Dig irrigation kit. First thing on the list, of course, is the Arduino Explore IoT Kit, and have that here. It was $130. I bought it directly from Arduino. You might be able to get it on Amazon as well. But anyway, it's has all the sensors you probably need for this project. There's a great how-to by Practical Engineering channel on how to build one with the separate sensors and putting that all together, but that was made multiple years ago, and now this kit is available with most of the sensors you need, really all of them, directly on this carrier IoT board that is part of this kit. And this includes 5 RGB LEDs all around the board, the round OLED display that you can put your data on, onboard sensors for temperature, humidity, pressure, light, gestures, and proximity. There's also a piezo buzzer that you can assign if something happens, say you hit a temperature level, you can have the buzzer go off. And there's an IMU, which is the 3-axis accelerometer sensor and 3-axis gyroscope sensor. I'm not using that, but I'm sure that would be an interesting project to make as well. The 224-volt relays, these up here. I'm using one right now for the relay that opens the hose valve. And then I will possibly use the second one to also, from a temperature level, run a small 12-volt fan because I'm getting some high temperatures when I have the box all the way closed. And I'll still have to try to keep it waterproof, but we'll be using that relay as well. So there's so much built into this carrier that keeps you from having to add individual parts to the system. So it's really convenient and probably worth the money. There's also a micro SD card holder on the bottom here. I actually have an SD card in it, but I'm doing most of my data capture to the cloud with Arduino's cloud. But you could also set it up so that this will take the data as well. You just do it with encode. And there's a plug-and-play Grove connectors for the external sensors. I'm using 2 of them right now, one for the voltage sensor and one for the capacitive soil sensor. And this is the capacitive soil sensor that comes with the kit. That's the one I'm actually using. I've built a 3D cap for it to keep it more waterproof, but this is the one that comes with it. Yeah, there's some issues with these as far as how you power the device, whether they're going to be working well from different various levels of power, whether you're bringing in like 5 volts to it or you're using the 3.7 volt from the battery. Sometimes these sensors don't work well off the battery, so I'm not using the battery right now. And of course, there's the 18650 battery holder that slides right into this spot here. And there are some capacitive soil sensors, moisture sensors that will work probably from the battery. My experience with the battery, though, is that it wasn't working with the capacitive soil sensor that came with the kit, and it wouldn't run all the way through to the next day. And I'm using solar to charge the battery, and it wasn't charging enough to keep it going all the way through to the next day. So I actually have a home-built battery that I have added to it. And some things to know about this particular board. It's a 12-bit board, which means when calibrating anything, you're looking at a resolution of 4095 instead of 1024. This is actually important when you're calibrating the moisture sensors, and if you want to monitor the voltage of either the battery or the USB input like I'm doing, it ends up being another of the gotchas, so you do have to set those, and I will cover how to set all that in the next video. Another thing to know is that there's now a Rev 2 carrier now, supposedly with some higher quality sensors. Has better temperature, humidity, and barometric pressure, air quality, and ambient light sensors, I believe. One thing also to know about the capacitive touch buttons, they do need some tweaking, so we'll go over some of that. I'm only using 3 of the 5, and that's actually all that are working right now. I probably have to adjust the sensitivity of the other 2, but right now they're not working. And maybe this is something they fixed in the Rev 2 board, which is now coming, and I actually have one on the way, and I may replace mine with this. We'll see. Something to know about the soil moisture sensors. I mentioned a little bit about the fact that if they're not powered correctly, they do not work as perfectly as you would like them to work. Sometimes not at all. And you do have to calibrate these as well. There's a good one and apparently a bad one, and this is all having to do with a timing chip on the moisture sensor itself. If you can see it, it's really tiny writing. You can find out whether you have the good one or the bad one. There's another video on YouTube put in by a guy that basically tested all these and found out which ones were the working ones and which ones maybe less so. My timing chip on mine is actually not the good one, and I have been able to get mine to work. So I think it really is very much hit or miss. As far as the waterproof case, you could probably use the case, as I mentioned, that came with the IoT Explore kit, but with this one, as you can see, there's a board that you can actually put your boards on and tie them down with offsets like I've done with mine. The MPPT solar controller I have on there, the batteries in there, and the see-through screen allows you to see the IoT carrier screen, and you can also use the capacitive touch buttons through the front cover. So that's why I chose to use this, and it's been working great for me. It's a 5.9 inch by 5.9 inch box, and it came with 2 compression cable glands to bring the cabling in while still maintaining the waterproof seal. So for wiring and connectors, I'm showing $42, but I really only use about $12 of that material. You have a short right angle USB connector that just kind of helps everything be tidy in the box. And that runs from the Dirac step-down converter into the Arduino microcontroller. And then some 3-conductor outdoor wire. This is mainly used for LEDs, powering LEDs outside. And this is what I'm using for the soil moisture sensor and to get to the hose solenoid from the control box. Then I have some 200mm black and red JST XHP connectors. And these are what I'm using to connect things like the battery and the Dirac voltage step-down converter on the voltage side. Things that I think I'm going to be taking out and replacing occasionally. And I have some electronic silicone protectant that I'm using. I'm using this to help waterproof mainly the soil moisture sensor, but you could probably use it for waterproofing other things. And then the hose solenoid and adapters, that was 28 total. It was 18 for the solenoid, but it looks like I could have gotten one for possibly as low as $12, but I think the shipping dates on those were further out. This is a normally closed solenoid valve, and it requires very little pressure to work, which is important for me due to my feeding this with gravity water pressure from the rain barrels. If you're powering it from your hose, this is not as much of a consideration. You might be able to get one cheaper. But if you were drip watering and also using your hose faucet, you might be using a 25 psi pressure limiter hooked up to your hose faucet, as most of these need to have the pressure turned down. And one of those actually does come with a dig irrigation kit. The adapter kit for the solenoid valve was a must, at least for me. The threads on this, it can be squirrely when you're trying to mate them up with plastic threaded hose connectors from the dig irrigation kit. You just have to be careful when attaching everything. It's been pretty leak-free so far. And then the dig irrigation kit, that was from a big box home improvement store. It was $29. And that's been a great little kit, and it's had most of what I needed, but I did have to go pick up a few other things to complete 2 raised beds. I needed some extra elbows, I think at least 2 extra T's, and I needed a second hose to rain barrel connector because I'm running 2 rain barrels. I'm also going to cover the solar parts list as well because it's how I'm powering my system, but you could simply bring power out to the control box and run it off an AC to USB plug as you would charge your phone with, but you have to make sure it feeds at least 2 amps. One of the 5-volt direct to USB plugs would probably be better. Basically, it's a plug that plugs directly in an outlet and just has a wire directly to the USB. They make them for Raspberry Pis and Arduinos, so that's actually probably a better source of voltage. I have $20 here for my battery. Those are the batteries that I built. I buy these in bulk. I bought about 300 of them, so I'm just kind of estimating $20 for the materials to actually build that battery. And then the draw DC to DC buck converter, that was $13, and that's what I used to take the 12 volts from that battery I built down to the 4 or 5 volts that go into the microcontroller through the USB cable, the little short mini one. And then I have an eBay MPPT solar charge controller, and that's what takes the 18 volts coming out of my solar panel down to the 12 volts to charge the battery pack. And that's pretty cheap. You can find them on eBay. You can also find them on Amazon, but this is not a high dollar one, has no display. You actually you set the settings with a screwdriver and a potentiometer on the input and the output side. And then the MC4 connectors that you can see that I'm plugging directly into the solar panel, into the box, I got those from another connector that I had that I've been cutting up piece by piece and using kind of as, so I'm not gonna really count that. But, and then the 100-watt solar panel was about $85. So that's all the parts that I'm using to power it. But like I said, you could power it directly from your house if you wanted to.
Well, that's it for the parts list. The next installment will be a step-by-step run-through of writing the code to make all this work and some of the gotchas to look out for when building something like this. If this is content you'd like to keep seeing, please hit the like and subscribe button and we'll be notified when there's new content, including the remainder of the videos on this project.